Hey guys, let's start with solving question number 11. That is, if y is equal to e raised to the ax sine of bx plus c with r is equal to square root of a square plus b square and theta is equal to tan inverse of b by e, b by a. So we have to find its nth derivative. Here y is a product of two functions, that is, it is in the form of u into v, and we know that if a function is given in the form of u into v, then y1 is its first derivative is v into du by dx plus u into dv by dx. So we can differentiate the given function with respect to x as we are taking first derivative of e raised to the x, that is a into e raised to the x, into second function as it is, that is sine of bx plus c, plus e raised to the ax as it is, and derivative of sine of bx plus c is cos of bx plus c into b. So this is our first derivative, that is y1. If we replace our a by r cos theta and b by r sin theta, then it becomes e raised to the ax r cos theta sine of bx plus c plus e raised to the ax into r sin theta into cos of bx plus c. So we can take e raised to the x into r common, so this can be written as r into e raised to the x. This is sin a cos b plus cos a sin b, so this can be written as sine of bx plus c plus theta. So this is our first derivative. So we can generalize this up to nth derivative, because here observation is, or our pattern of the derivative is, if we are differentiate the given function, then we are getting one extra term, that is r, and one theta extra, that is bx plus theta, which means if we are differentiating given function with respect to x again, then we will get r square e raised to the ax sine of bx plus c plus 2 theta and so on. So we can generalize this up to nth derivative as r raised to the n e raised to the ax sine of bx plus c plus n theta. So this is nth derivative. So this is nth derivative of y is equal to e raised to the ax into sine of bx plus c, where r is equal to square root of a square plus b square and theta is equal to tan inverse of b by. Here question number 12 is similar. In question number 12 we have to find the nth derivative of e raised to the x cos of bx plus c. R is the square root of a square, r is square root of a square plus b square, and theta is equal to tan inverse of b by a. So its answer is similar, that is e raised to the ax into r raised to the n cos of bx plus c plus n theta. Because method is similar, we get similar answer. Next question, question number 13. In question number 13 we have to find y is given as y is equal to e raised to the x, we have to find n. We know that if y is equal to e raised to the ax, then our yn is equal to a raised to the n, a raised to the x. So here value of a is 2, so here yn is 2 raised to the n e raised to the 2x. So this is nth derivative of y is equal to e raised to the 2x. So next question, question number, that is question number 14. In question number 14 we have to find, the nth derivative of y is equal to ax plus b. This is again a simple question. This can be written as e raised to the ax into e raised to the b, where e raised to the b is constant. So we can just find the derivative, nth derivative of e raised to the ax, but we know that nth derivative of e raised to the ax is a raised to the n e raised to the ax. So nth derivative of given function is a raised to the n into e raised to the ax plus b. So this is nth derivative of y is equal to ax plus b. Our next question is, that is question number 15. In question number 15 we have to find the nth derivative of y is equal to 2 raised to the x. We know that if y is equal to a raised to the x, then its nth derivative is a raised to the x log a. So this can be written as, here value of a is 2, so this can be written as yn is equal to 2 raised to the x log 2, 2 raised to the x log 2. So this is nth derivative of 2 raised to the x. Next question, that is question number 16. I think question number 16 can be solved in